Okay. Now let's take a look more into polynomials. Okay. So the general form of a polynomial, general form of a polynomial is something like this. So f of x is equals to a naught plus a1x plus a2 x square plus a3 x cube plus dot 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 plus an x to the power n. Now this is called the general form of a polynomial. So this x means this has a power of 1, and we have written nothing here. That means it is actually have x to the power 0. Something to the power 0 is equals to 1. So this a, these values of a, this a0, a1, a2, these are called coefficients. Okay, these are called coefficients, and the maximum power of the x, that is x to the power n, this maximum power n is called the order of the polynomial, known as the order of the polynomial. So when I'm writing something like this way, f of x equals to 5x square plus 6, the order of the polynomial is 2, and the general form, if I write the general form, in the general form it should look like this: 5x square plus 0 into x, that's something we are not writing, plus 6. So this is my a0, this is my a1, and this is my a2 according to this equation. Okay. Achha. Now what we are trying to do is that we are trying to find the root of this polynomial. Okay, that's our task. Find the roots. Find the roots. Okay. And for that there are different methods that are involved. Okay. Different methods are introduced. Now the roots of a polynomial, okay. Say for example, let's start with a linear equation. Say for example, f of x equals to twice x plus 5. Okay. What is the root of polynomial? You know that if I just make it 0, and so x is equals to minus 5 divided by 2. This value of x, okay, this value of x is the root of this equation, and this is the first order polynomial. So we can actually calculate it directly. Okay, x equals to minus 5 by 2. What about a second order polynomial, quadratic polynomial? Say for example, x square minus 4 is equals to 0. Then we know that x square is equals to 4. So we can calculate x is equals to plus and minus 2. Okay, so this equation, this polynomial has two roots. This polynomial had one root. Okay, let's check another one. So x square plus 5 is equals to 0. Okay, so now I have x square is equals to minus 5, a minus sign. So what is the difference? Now if I try to make x, it becomes root over minus 5. So when I have root over a negative, so that means I no longer have any real root. Now I have complex roots. Okay, so the roots can be real, can also be complex, and as you can see there, I will have two roots actually. So how many roots should be there, and how it is related? Let's try to understand those things. The first thing is, so how many roots should be there? As you can see, when I had order is equals to 1, I had at least, and I had only one root. When my order was 2, I had 2 roots. So if my order of the polynomial is 3, then I will have 3 roots. Okay, so let's start here. The first thing is the roots. Can be real. Roots can be real or complex. It can be both. The second thing is the number of roots. This sign means number of. Okay, the number of roots is equals to the order of the polynomial. If it is second order equation, there will be 2 roots. If there is a third order equation, there will be 3 roots. Okay, like this. Okay. In n order equation will have n roots. Now when I had, as you can see, this one root, this one order, first order, I had one real root. So if we come here, so the 3 is if n is odd, if the order is odd like 1, 3 or 5, what you can decide? You can decide that it will have at least one real root. So a third order equation will always have one real root. A first order equation will always, the root of a first order equation will always be real. It cannot be complex. Why not? Because that is number 4. When I have complex roots, they come in conjugate pairs. Conjugate pair. So if you remember, that is like a plus bi, a minus bi. The real portion is same, only the difference in here. So when I have complex root, it will always be in pairs as a conjugate pairs. So if my order equals to 3, okay, it can have one real root and 2 complex root, or it can have all 3 as real root. Okay, but it cannot have 2 real roots and 1 complex root. That is not possible. Okay, so I hope you got the idea. So these are the basic thing. Now the question is, how do we calculate the root? How do we find the roots? Okay. So different methods are actually proposed to find the root. Okay, let's come here. Say for example, when you have a quadratic equation, the general form of the equation is y is equals to ax square plus bx plus c. And for this, and you have already know the root is like this, minus b plus minus root over b square minus 4ca divided by twice a. So as you can see, plus minus, that means there are 2 possible values that we will get. Since I have second order, I should get 2 values, I should get 2 roots. Okay, now this b square minus 4ca, this portion is interested. Okay, we are interested in this portion. This has a name, and this is called discriminant. So what is its significance? Let's name it as d for now. So d is equals to my b square minus 4ca. Okay, so this discriminant will decide what kind of root is gonna be there. Okay, say for example number 1, if d is positive, what we'll get? If it is a positive value inside, that means the output will always be real, because it can be root over 20 or it can be root over 100. We always get a positive output from here. Then I have minus b plus something positive, minus b minus something positive. So output is always real. So when I have d is equals to positive, I will have real roots. Okay, I will have real roots. That is one thing. Okay. Now when I have, if I have d is equals to 0, if this whole portion is 0, then root over 0 is equals to 0. So I will have only one root. There is no plus minus, is no nothing. Okay, so I have a single root from this equation. I will have single root. So what about d is equals to negative? And if d is equals to negative, what we will get? If d is negative means I have something inside minus something, whatever there is, that is the point. So that means something, say for example minus 20. When I have root inside 20, I get the I, that is equals to root over minus 1. So I will have complex root. I will have complex conjugate roots. Okay, so three different scenario. Based on the value of the discriminant, I will get three different cases.